All right, guys, I want to go through a few problems related to the sequence idea that we started yesterday. So I'm going to go through this first one with you, kind of showing you an example of how you might apply it to a certain situation. So here's the situation we've got. Trixie, she wants to create an especially tricky arithmetic sequence. What she wants is the fifth term of the sequence to equal 11. She wants the 50th term to equal 371. Or in other words, she wants t of 5 to equal 11. And she wants t of 50 to equal 371. So here's what we want to try to figure out. Is it possible to create an arithmetic sequence to fit her information? If we decide it is possible, we want to find the sequence generator, we want to find the initial value, and then eventually we want to find the equation for the arithmetic sequence. If it's not possible, then we'll try to figure out, okay, well, why is this not possible? All right, well, a lot of key parts to this, but probably the number one key part to this is the fact that she wants an arithmetic sequence. So we said if it's arithmetic, then we're really looking at something that's linear. So a linear situation should have a slope. It should have a y-intercept. But in terms of sequences, it should have a generator, and it has a t of 0 value. So ultimately, if this is going to work, then we should be able to find some equation related to this situation. But that equation would have to be linear, and we'd have to be able to find the slope, we'd have to be able to find t of 0, and it would have to fit the information we're given. Well, we're kind of going to go back and forth between the ideas of sequences and functions, but they both have the same idea when we look at inputs and outputs. We talked about you could create a table for sequences. Right now, we'd only have two values in that table. One of them would be when n was 5, because that's the input, the term was 11. And then on down the road, we would have an input of 50 would give us 371. Well, let's see if we can find that generator, or if we were thinking in terms of a line, we're thinking about the slope. Well, with the slope, it's how much has the output changed over how much has the input changed. So let's think about how much our terms have changed from the initial one they gave us, or the fifth term in our list, to the 50th term. Well, to get from 371 to, or from 11 to 371, we've gained 360. Then we have to think about, well, how many steps or how many terms did it take me to get there? Well, from 5 to 50 is 45 steps, or 45 terms. So if I go on a total of 360, it's taken me 45 terms to do that. I can figure out what each one is by dividing those two. So if I were to take, it's not very good, 45. If I were to take 360 and divide by 45, I find out that each step was 8. Or this is my generator. So far so good. Now we're going to try to figure out the t of 0 value. And one way I can think about that is, well, right now I'm at the 5th term. So I've got to backtrack to the 0 term. Well, if I backtrack to the 0 term, that means it's going to take me 5 steps to get there. Each step, we decided, is worth 8 values, because we increased 8 as we go. So if I backtrack, I'm going to take 8 away each time, and I'm going to do that 5 times in this case. Or in other words, I'm going to have to subtract 40 from the 11 that I used to have. So if I take 11 minus 40, I get negative 29. That would be my T of 0 problem. So finding her sequence, T of n would equal 8n, that was our generator, minus 29 because that was our T of 0 value, or the initial term. Excuse me. So that might be one way we attack it. Another way you can think about this one, though, is since we know it's arithmetic and we know that means it's linear, go back to what we know. What we know is a lot about lines and equations of lines. Let me copy here. So let's see how we can use the idea of lines to help us with this problem. When they gave us this information that T of 5 is equal to 11 and T of 50 is equal to 371, that's really no different than giving me the ordered pair of 5, 11 and another ordered pair of 50, 371. We know the generator is the same thing as the slope, so I could take these 2 points and I could find the slope. Well, that's taking 371 minus 11, dividing it by 50 minus 5, or we're doing 360 divided by 45, which is what we did earlier. That tells me the slope is equal to 8. And then most of the time we plug that into a y equals equation and got to this point. And all we'd be missing is the y-intercept, which is really our 0 value. So I'd plug in 11 maybe for y, because that was a value I was given. I'd plug in 5 for x, and I'd solve for b. And when I do that, I end up taking 11 minus 40, which is what we did earlier, and I get my b value of 29, negative 29. So in terms of a line, the equation would be y equals 8x minus 29. In terms of a sequence, I would say T of n equals 8n minus 29. So it's okay to use those ideas that you already are comfortable with lines when we're looking at an arithmetic sequence. All right, let's see what's going on with this next one. This one talks about Cody. And Cody, 7 years ago, he found a box of old baseball cards in the garage. Since then, he starts adding a consistent number of cards to the collection each year. So he has 52 cards in his collection after 3 years. Right now, he has 108 cards. So a few things we want to know. First of all, they want to know how many cards were in the original box. And they want to know, well, is this T of 0 or is this T of 1? And we want to write the first few terms of the sequence. And then we want to know, well, if Cody plans to keep adding to this collection, then how many cards will the collection contain 10 years from now? And then finally, we're going to try to come up with an equation that helps us figure out how many cards after n years. And we can make a prediction in the future. All right, so let's start with the first one here. Well, let's go back to our information. They said 7 years ago, he found a box of old baseball cards in the garage. So if we think about current time, right now we're in 2021. So that means in the year 2014, he found baseball cards. He said since then, he's added a consistent number of cards to the collection. He had 52 cards in the collection after 3 years. So in the year 2017, 3 years after he found it, he had 52 cards. He says right now he has 108 cards. So in the year 2021, he has 108 cards. So that's the initial information. Well, number one, they want to know how many cards were in the original box. Well, the original box would be what he found in 2014. That would be considered T of 0. Because when he found the box, he hadn't added any to it. He had 0 years of adding to the collection. So let's see if we can find that value. Well, in order to find that value, I need to figure out how many cards has he been adding each year as he went along. Well, the only information we know about is what happened 4 years ago and what happened this year, or how many he has this year and how many he had 4 years ago. So it looks like he's gone from 52 to 108. So in other words, he's added 56 cards in the span of 4 years. So if I take 56 and I divide that by 4, I find out he's been adding 14 cards every year. So if I want to figure out how many he had in the year 2014, I've got to take 14 cards away each year. Or I've got to take 14 away for 3 years. So 14 times 3 is 42. So if I take 52 minus 42, I find out that he started with 10 cards. Or T of 0 is 10. Okay. Number 2 wants to know, well, how many cards will he have 10 years from now? Well, right now he has 108. He's going to add 14 a year, and he's going to do that for 10 years. Or he's going to add 140 to the 108 that he already has, and he's going to end up with 248 cards. So if we put it all together and write an equation, our equation would be looking at T of n, the slope or the generator, or how many cards he added per year was 14, so I'd say 14n. And he added that amount to how many he started with initially, and that was 10. So our equation would be 14n plus 10. All right, I'd like you guys to take a look at this problem here. We're back to Trixie, and Trixie now wants an arithmetic sequence with a generator of -17, and she wants the 16th term to equal 93. Or in other words, she wants T of 16 to equal 93. Here's what I want you to try to figure out. Is it possible to create an arithmetic sequence to fit her information? If so, I want you to go ahead and find that equation. If not, I want you to think about, well, why would this not work? So I'd like you to go ahead and try this one. So pause the video and come back and see how you might attack this one. All right, let's see if this one's possible here for Trixie to do. So if Trixie's going to make this work, we know that the sequence is going to have a generator of -17. So already we know if the equation works, we're going to have -17n. But we've got to figure out still what our initial value is going to be, our T of 0 value. Well, let's think about what we have to work with. Well, we don't know that T of 0 value, but we do know the 16th term, or when n is 16, so I can plug that in. That the term value is 93. So I can plug that in. My question mark is, what's my T of 0 value? Well, I can find that by finding this equation, or solving this equation. So if I take -17 times 16, I have 93 that's equal to -272. And then I can add 272, and I find out T of 0 is 365. So my equation for this situation is T of n equals negative 17n plus 365. So based on the information they gave me, that was possible. And now we have that equation. So as we look at sequences, we'll kind of tie some different things together. We'll look at just here's some values, find the equation. But we'll also try to tie it to different situations and see how we might apply those things. So now that you've finished watching the video and maybe going through those problems, I am going to give you one exit ticket problem that I want you to try, and it's going to be related to what we've been doing here. So you want to make sure that you do that on the Edge Learning page.